All right, square root functions. Woo! Come on, computer. So we're going to talk about graphing these guys, but before we can go ahead and graph it, we need to look at what a basic one looks like. So a square root function is essentially half of a parabola. So we just got done with parabolas, which I know you loved oh so much. And essentially, we take this parabola, undo. We're essentially taking this parabola and we're flipping them sideways. And when we do that, we only talk about the positive versions of it. We don't necessarily care about the negatives. So we're going to have essentially half a parabola looking guy. Sideways parabola. When I take that guy and I multiply it by a negative, he's going to reflect, hence the reflection part. And that means that he's now going to be going downward. So he's going to look like that. If I have, say, 2 here, so I have the square root of 2x, that guy's going to be getting bigger. So he's going to stretch and get really, really tall. If I have, say, a half, he's going to take really long time to get big. So he shrinks. I can have a stretch and a reflection at the same time. So say I have a -2. He flips upside down and gets really big this way. Say I have a -1/2. He's going to take a really long time. Upside down. When I'm dealing with pretty colors, when I'm dealing with a number underneath my square root, we go left or right. And I'm going to show a couple more examples of this in a moment. If it's x plus, you go left. If it's x minus, you go to the right. It's opposite. So typically you're used to going left when you're negative. Just trust me when I say we're going to go left when we add, if there's a plus in the middle. I could show you the reasoning, but I feel like, I love you, but I feel like I might confuse you a little bit more. So I'm not going to. So if you see a plus, you go to the left. If you see a minus, you go to the right. If you have it on the outside, that's up and down. And if it's plus k, you go up. If it's minus k, it goes down. So this one's normally like you see it. If he's outside, he's normal. And then obviously just the combined, so moving up, down, left, and right at the same time. Yay! So what we're going to get hopefully used to is trying to pick out which way we're going to go. So this is just going to be the basic parent function. So he's not going any specific way. This is what everything's going to look like when we translate it. My domain are going to be my x values. My range is my y's. Intercepts are where it hits the y and x axis. So before we answer these questions, we're going to actually fill out our chart. And when we talk about the square root of something, I can't take the square root of, say, -4 in your calculator. Try and take the square root of -4. It gives you an error, essentially. It tells you it's a non-real answer. That's because it doesn't exist. So when we deal with square root functions, unless we're moving left and right, which we'll talk about in a moment, we're going to always start with 0. And I like to take square roots of perfect numbers. So I'm going to do 0, 1, and 4. 2's not perfect. That's not going to give me a nice answer. 3's not perfect. It's not going to give me a nice answer. I want to use just square roots. So the square root of 0 is 0. Maybe. The square root of 1 is 1. And the square root of 4 is 2. So I have a dot at 0, 0. I'm going to make this a little bit thicker so you can see that that's easier. I have a dot at 1, 1. And a dot at 4, 2. 2, 3, 4, 1, 2. So it means that when I connect my dots, that was really bad. The idea is we're getting bigger. So my domain deals with my x's. In this case, as you can see, we're getting bigger each time. I start with 0, then 1, then 4. So my domain is greater than or equal to my smallest x value of 0. Same thing with my y's. They're also getting bigger, and it's getting bigger than my smallest y value, which is 0. The x-intercept is where it hits the x-axis. So here's my x-axis right here. Maybe, come on, there we go. And that hits at 0, 0. My y-axis is the other one, it's the up and down one. Come on, there we go. And he also hits at 0, 0. Sometimes they hit the same spot, sometimes it's none for both of them. It just depends on what the graph looks like. Okay. So, before we get started, my $1 million question is, what does vertically mean? Up or down? So we're going to go either up or down. So if I go back a moment, I go to my chart, my guy with my chart, and I clean it up a little bit because I want to look at what I'm going to talk about. Maybe it's a little bit too much. That's this guy. Oh, I erased so much. Go back. I'm sorry, my computer is wanting to hate me today. He's this guy. So what I'm looking for is where did it go? I erased too much. Ah, I suck. Whatever. We're just moving forward. Done. Done trying to be smart. Showing you cool things. I'm really just over my computer tonight. So, since my 2's on the outside, he's going to be going up because he's positive. When I go up and down, my x values are not going to change. So I'm still going to use my 0, my 1, and my 4. I don't know, can you see that? Or is my face in the way? Okay, you can see it. Sorry. So when I plug in 0, I have the square root of 0 plus 2. Square root of 0 is 0. 0 plus 2 is 2. I have the square root of 1 plus 2. I guess I should do this for you. Square root of 1 is 1. 1 plus 2 is 3. Then I have the square root of 4 plus 2. Square root of 4 is 2. 2 plus 2 is 4. So we're going to go ahead and plot my dots. So I have 0, 2, 1, 3, and 4, 4. 1, 2, 3, 4, 1, 2, 3, 4. And connect my dots. So my vertex point is talking about where does it start. Well, we talked about how we can't have negatives. So my vertex in this case is going to be my very first point, which is 0, 2. My x-intercept is whatever hits the x-axis. Well, does anything hit that line? Nope. So there is none. My y-intercept Is that anything that hits the up and down? Do we have a point that hits that red line? That's my vertex point as well. So again, we'll be using a lot of the same points several times. Next thing we're going to talk about is my domain. Domain is x's. My x values are getting bigger. They're getting bigger than 0. My range is my y's, and they're going to get bigger than the smallest y. And my smallest y value is 2. We did it! Okay, so what way am I going to go if I'm negative? We're going to go down. So again, because we're going down, my x values don't change. Stay with 0. We stay with 1. And we're going to stay with 4. So the square root of 0 minus 1. Square root of 0 is 0. 0 minus 1 is negative 1. Okay. Then I have the square root of 1, which is 1, minus 1, which is 0. And I have the square root of 4 minus 1, which is 2 minus 1, which is 3. Times 0, negative 1, 1, 0, and 4, 1, 2, 3, 4. That's not the best graph, I'm sorry. Okay, I can't count, can I? Maybe that didn't look right. Yeah, we're gonna do this. 2 minus 1 is not 3. It's 1. So that means that point's wrong. Which means that point should be 1, 2, 3, 4, 1. Right there. Hey, that looks a little bit better. I was looking at that and I was like, I don't know why this looks weird. Ta-da! Okay, so my vertex is 0, negative 1. Okay. Come on, computer, stop being dumb. My x-intercept is, where does it hit this line? Well, it hits at 1, 0. Where do I hit on my red line? That one we are 0, negative 1. My domain is x's, and they're getting bigger than the smallest x. Ah! Come on. And my range is y's. They're getting bigger than negative 1. Horizontally. So left or right. I'm doing this with my mouse, so that's pretty impressive if I do say so myself. So we're going to go left or right, and it's going to be the opposite. So up and down are exactly what you see. So if you see plus, you go up. If you see minus, you go down. However, if you see plus, typically you're used to going to the right, and we're going to go to the left. So when I deal with these, my x values are going to change. So we know we're going to go to the left. And in order to manipulate my values so that they work for me, what I'm going to do is I'm going to take my normal values off to the side. I don't want to scroll. I'm scrolling down so my face isn't in the way. I'm going to take it off to the side, and I'm going to subtract my 3. And you're going to see why in a second. So 0 minus 3 is a negative 3. So I'm going to use that as the x. 1 minus 3 is negative 2. 4 minus 3 is 1. Now I'm going to plug in my newly found x values into my equation, which is the square root of x, so negative 3 plus 3. And notice how it's in the square root, so I have to do that part first. So what is negative 3 plus 3? 0. What's the square root of 0? Ah, do you see where we're getting here? Maybe not yet. Let's try another one. We have negative 2 plus 3. What is negative 2 plus 3? It's 1. What's the square root of 1? Oh, I see a pattern coming on. Okay, let's try the next one. 1 plus 3. What is 1 plus 3? What's the square root of 4? So what we did by doing this little part here is we manipulated the x values so that way when I went to find the square root, I'd have nice, pretty answers. We like pretty answers. We like whole numbers. Okay, so my vertex is going to be at negative 3, 0. Oh, I didn't plot any of my points. What am I doing? I don't know what I'm doing. I can't answer any of these questions. I can't see anything. So I'm at negative 3, 0. So I'm going to go to the left 3, up none. That's a really poorly placed dot. Let's try that again. A little better. Then I have negative 2, 1, and I have 0, 2. Connect my dots. Hey, it looks like half parabola. Okay, so my vertex is at negative 3, 0. Where do I hit on my x-intercept? Well, that's at also negative 3, 0. Where do I hit on the y-intercept? Well, that is at... I missed a spot again. Back up for a second. Yes, I know. I'm telling you to back up. This is at 1, 2. So this dot doesn't exist. So because he doesn't hit the intercept at a specific actual point, we're going to say he's none. Because that point doesn't exist there because I can't count. He does hit, but it's at such a inconvenient answer for us, we're not going to find it. We're just going to say it's there. Okay. Ow. My domain's my x's, and they're getting bigger than a negative 3. My range is my y's, and that's getting bigger than a 0. We've gone up, down, and left. Please tell me which way I'm going. Going to the right, stupid. $5 you said that. $5 you said we're going to go to the right, you stupid. It's February 22nd. I'm betting you that. Okay, so if I go to the right, typically we're going to add. So I'm going to do the opposite of what I just did on the problem before. So we went to the left, so we subtracted. Since I'm going to the right, I'm going to add. So I have my 0 plus 2, my 1 plus 2, and I have my 4 plus 2. Because those are the original perfect squares. 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6. So in here I have 2 minus 2, which is 0. And the square root of 0 gives me 0. Then I have 3 minus 2, which is 1. Square root of 1 is 1. Then I have 6 minus 2, which is 4. And the square root of 4 is 2. So I'm plotting my points. I have 2, 0, 3, 1, 4, 5, 6, 2. Connect my dots. And I answer my questions. So my vertex is at 2, 0. The x-intercept is where does it hit that line, which again in this case it's 2, 0 as well. Do I hit my y-intercept at all? Nope. So I don't have one. My domain's my x's. They're getting bigger, then not 0. They're getting bigger than 2, and my y's are getting bigger than 0. I looked in the wrong column. Sorry. Okay, we're going to do all of this together. So if you want to pause and come back at this time frame, go ahead. So what we're going to do is we're going to figure out our x's. And I want to make sure I have enough room to write, so I'm going to scoot this over a smidge. If I see, if I see plus underneath, we know we're going to go to the left. If I see plus outside, we're going to go up. Doesn't matter going up to change anything, but because I'm going left, I have to change. So left is usually negative. So I'm going to take by 0, 1, and 4. And I'm going to subtract whatever's in there. So in this case, it's 1. So 0 minus 1 is negative 1. 1 minus 1 is 0. And 4 minus 1 is 3. Okay, now we're going to go plug those in. And I'm going to do my work. I don't want to move that too much. I'm going to do my work down here underneath my graph so you see what I'm doing. So I'm going to plug in negative 1 first. So I have negative 2 times the square root of negative 1 plus 1 plus 3. I'm going to scroll down so I can have room to write. So negative 2 times the square root of 0, because negative 1 plus 1 is 0, plus 3. The square root of 0 is 0. 2 times 0 is 0. And 0 plus 3 is 3. Okay, now I'm going to do the same idea, only now instead of negative 1, I have 0. That was my shoulder, by the way, in case you heard that pop. I have negative 2 times the square root of 1 plus 3. Square root of 1 is 1. Negative 2 times 1 is negative 2. And negative 2 plus 3 is negative 1. And my last point, I have negative 2 times the square root of 3 plus 1 plus 3. So negative 2 times the square root of 4. So negative 2 times 2. Negative 2 times 2 is 4. Negative 4, excuse me. So I have negative 4 plus 3. And negative 4 plus 3 is a negative 1. That didn't work out. What the heck? This is a positive 1. Green is positive 1. I told you I can't count today. I'm sorry. Negative 2 plus 3 is positive. Ooh. So it should be 3, 1, and negative 1, which makes sense because we're going down. Okay. So I'm going to go ahead and plot my points. So I'm left 1, up 3. I am at 0, up 1. And I'm to the right 3, down 1. So when I connect my graph, where you have flipped upside down, so to my domain, my x's are still getting bigger. They're getting bigger than the negative 1, but my y's in this case are getting smaller, and they're getting smaller than 3. I'm getting terrible, terrible handwriting today trying to do all these, so I'm going to type this next part. So then it says to tell me any characteristics you see that happened. Well, first things first is that it flipped. So it flipped upside down. Okay. It also moved to the left, and it went up compared to my normal parent graph of being at 0, 0, and it's stretched by 2 because I have that 2 out in front. So all of those 4 things happened to it. That's a lot. Ooh, home stretch. That is a blank one. Alright. Sorry, I was getting ready to get my blank pages bothering me. OCD. Okay. So if we are positive, we're going to go left. So I have my 0, my 1, and my 4. Left is negative. I'm going to subtract 6. 0 minus 6 is negative 6. 1 minus 6 is negative 5. 4 minus 6 is negative 2. So again, I'm going to do my work down below. So I have 1/2 times the square root of negative 6 plus 6 minus 4. Negative 6 plus 6 is 0. I'm trying to write a positive sign, and I don't want a plus, I want a negative. Square root of 0 is 0. 0 times 1/2 is 0. And 0 minus 4 is a negative 4. Next I have 1/2 times negative 5 plus 6 minus 4. So I have 1/2 times the square root of 1 minus 4. Square root of 1 is 1. A half times 1 is 1/2. Minus 4 is negative 3.5. Alright, last one on here is we have negative 2. Negative 2 plus 6 is a 4. Square root of 4 is 2. 2 times 1/2 is 1. And 1 minus 4 is a negative 3. So these points are going to be really close. So we've got -6, -4. I've got -5, -3.5. I've got -2, -3. So when I connect it, it's really little. So it really doesn't go up much, but that's again because of the shrink of a half. So the domain is my x's, and they're still getting bigger. And they're getting bigger than -6. My y's are also getting bigger in this case, and they're getting bigger than a -4. We went to the left, 6. We went to the left, and we went down. We did not reflect, but we shrunk instead of stretched. We've shrunk by a half. Last bit. Home stretch. We can do it. Okay, what we need to do here is we need to do a little bit of factoring in order to get this so that I can describe my graph. Because I'm looking at something that is not similar to what we've been doing. So what I have to ask myself is, can I divide both of these numbers by whatever is potentially in front or a perfect square? And if so, I'm going to go ahead and do that and then simplify. So can I take 4 divided by 4? And can I take 12 divided by 4? Okay, I can do it. So what I'm going to do is take out of 4. And when I divide out of 4, I'm left with 1. Get real frustrated with the computer. I have the square root of 4. When I take out the 4, I'm left with the 1 minus 3. Well, the square root of 4 is 2, so I'm going to go ahead and take the square root of that. And what's left is the x minus 3. Then I'm asked to go ahead and describe the graph. So, because I'm going to go to a minusing, I'm going to go to the right. So I'm going to go to the right 3. And I'm going to stretch by a factor. Wow, I cannot spell today. Stretch by a factor of 2. And that 2 came from the square root of 4. One more problem. One more problem. Okay. So again, I see stuff underneath the square roots. I'm like, hey, I'm not used to that. Let's see if we can factor it out. And we divided by whatever was in front of the x. And the first example is 4. So hey, can I take 9 into 9 and 18? So 9 divided by 9 is 1. 18 divided by 9 is 2. And my plus 4 is on the outside. So make sure he does not come in the square root with him. They're not friends. They don't like to hang out. Square root of 9 is 3. So I'm left with x minus 2. Again, that plus 4 over there on the end. So this is my final answer. And we're going to say what happened. Okay, well, he is going to go, if he's minus, I'm going to go to the right. We're doing the opposite. We're going to go to right 2. We're going to go up 4. And we're going to stretch by 3. We did it! Yay!